Let's talk about environments for nested definitions. Last time I showed you the following example. I can create a makeAdder function, which takes informal parameter n. It creates another function within it, makeAdder k, which returns k plus n. Now the makeAdder function returns the adder function, which was defined within its body. So makeAdder, what it does is it creates a new function and returns it. It doesn't actually add things. If I load this function into Python, what happens? Well, I can create new functions on the fly. I can create a function add3 by calling makeAdder on 3, and now I have a function that adds 3 to things. I could add 3 to 4, I could add 3 to 5, I could add 3 to 6. And somehow part of this function add3 is the number 3 that gets added in. How is it that we have a function that has data within it? Well, let's look at the environment diagram and we'll understand exactly what's going on. So here's the example. I define makeAdder, which doesn't execute its body. It just defines a new function. Then I call makeAdder on the argument 3, which does introduce a new frame with the formal parameter n bound to the argument 3. Next, I define the adder function. That's the first step in the body of makeAdder. When I define the adder function, I create a new function value, and then I bind the name of the function adder to that value in the current frame, which notice is not the global frame. So the makeAdder frame and its environment have access to this adder function, but so far there's no way to refer to it from the global frame. But that all changes when we return. So what a return statement does is it brings information from a local frame back into the frame that was the current frame when we called this function in the first place. So we return back to a particular point. We were evaluating this call expression. And so when we return, we're going to go right back to the point where we evaluated this, and we were about to bind it to the name add3. So what is the return value that we're going to bind to the name add3? Well, here it is, the return value for this function that we got by figuring out what adder meant in the current environment and returning that value. And that value is this adder function. So in the next step, I return right back to where I was before, which was in the global frame, having evaluated makeAdder3, and the value of that was this function adder, which I bind to the name add3, using regular assignment. Remember, we can give multiple names to the same function. Okay, now we have add3, which is a function that adds 3 to things. How does it do that? Its body is just k plus n. Well, let's call add3 on 4 and find out. So we introduce a new frame with k bound to 4. Its parent is actually f1, the frame here. So even though we returned from makeAdder, we still have access to its contents because we have frames that we've created whose parent is the makeAdder frame, which contains the name n. I'll go through this in detail in a moment. But what happens here is that we evaluate the expression k plus n in an environment that starts with f2, followed by f1, followed by the global frame. We find k equals 4 right there. We find n equals 3 right there. And that's how we get the number 7, which is bound to result. And then we're done. So this right here is the environment diagram for the example I just showed you. Let's talk about it for a moment. Here we have a nested def statement. And we also have something we've never seen before, a parent of a function that's not the global frame. So what happens is that you set the parent of a function to be whatever the current frame is when that function was created. And how did this adder function get created in the first place? Well, it's part of the body of makeAdder. So makeAdder was the first frame of the current environment when this adder function was created. And that's why its parent is f1. So when the parent is f1, then we call the function adder. We copy the name down into the new frame. We copy the formal parameters down and bind them to the argument values. And we also copy the parent of the function as the parent of the frame. So here's an explanation for why we have parents of functions in the first place. It's so that when we call those functions, we can write down the correct parent for the frame. Now, why do we need parents for frames? Well, that tells us how to find the current environment. So the current environment, when we actually evaluate k plus n, starts with the adder frame, and then is followed by its parent, which is f1, followed by its parent, which is the global frame. I've abbreviated as G, just so I could fit everything on the screen. It's fine if you evaluate it as G as well. Okay, so now we have a 3-frame environment. If we look up the name k in that environment, we look here first, that k is 4, and we're done. If we look up n in that environment, we look first in the first frame of the current environment, but there's no n there. So then we have to look at the second frame, which is the parent of the first frame. That's n is bound to 3. And so we can get k plus n is 4 plus 3 is 7, and we're done. Okay, so what are the key points? Every user-defined function has a parent frame. In all the other examples we've seen, it's the global frame. But when you have a nested def statement, it won't be. The inner def is going to have the frame of the outer def's function call. The parent of a function is the frame in which it was defined or created. Every local frame has a parent frame, as we've seen. And the parent of a frame is the parent of the function called. So that is supposed to explain what I did here. When I created this adder frame, I copied its name, I also copied its parent annotation, and bound its formal parameter to its argument. So all the information that you need in order to create this frame correctly, adder parent f1k, is right here in the function value. So if you know which function you're calling, you know how to write down its frame correctly. So here's a little guide to how to draw environment diagrams so that you can draw them on your own without using Python Tutor. And that's really helpful because then you can understand even complicated examples. When a function is defined, you always create a function value that looks like this. Its parent is the current frame. So that's why when we created the adder function, we were in the makeAdder frame, and so we wrote down that the parent was f1, which was the label for this frame. Now we don't write down makeAdder because there might be multiple different frames called makeAdder, but each one will have a unique label, so that's why we use those. We bind the name to the function value in the current frame. So that's when we had the name adder referring to this function. When a function is called, we create a new frame. So we add a local frame titled with the name of the function being called. We copy the parent of the function to the local frame. And then we bind the formal parameters to the arguments in that local frame. Finally, we can execute the body of the function in the environment that starts with that local frame. If we need to look up names in that environment, we follow the parent to the parent to the parent till we reach the global frame. And wherever we find the name first, that's the value that we use.